I'm just going to take one very basic and very important question about the linked list. So we will do the linked list. And the second thing, there will be a question which is reverse a linked list. Reverse a linked list. So suppose we have a linked list, something like this, and we have different node here. Okay, and suppose we have this is connected to it, this is connected to it, and so on, right? And it is one, two, three, four, five, six. Now, after reversing it, it should be look like something like this: six connected by five. Sorry, one, two, three, four, five, six, and six will be connected by five. Five will connected by four. It's connected by 2, it's connected by 1. Means 6, 5, 4, 3, 2, 1, and it will be look like something like this, right? So in comparison of starting linked list and the resultant linked list, we are it is very clear that it become reversed. So we need to do this. And how we can do it? So there we can solve it. Suppose we have this linked list: one, two, three, four, five, and six. And it is connected to this, it is connected to this, it is connected to this, and this. Now, what we can do, we can take 3 pointers. Okay. And this is our head. This is our head. And this is our tail. And these all are the nodes, as I told in the previous video also. Right. So now we can take two more pointers. Let's take one after and let's take one before. And in the starting, we can keep it before the head. So means it is pointing to null. Before head, there is nothing now. So that's why we have keep doing it null. Now, what can we do? We can take it while head dot next. So we can define our and suppose it means we need to pass our head as a reference. So that's why I'm passing the current here, and I will take current here also, so that I cannot lose my head head reference. Okay. So yeah. Now first of all, I will update my after. After is equal to current dot next. Means right now my current is here. So after will become here. And so that's why after become here. And let's take the current. Current is equal to before that dot next. Before means only before. Why before? Before is null. So that's why in current dot next, we can point to null and see this. We need to make it tail, and in tail, in next it should be null, right? So that's why we are pointing the current dot next as before, because before is a null value, and here is a node in which nothing is present. So that's why we are point current dot next. We are taking from here and we are making here, right? And then we will update our before. Before is equal to current, and that current is equal to after. Means this before. For once current dot next updated, so we can move our head to head here, and we can move our current to here. And then again while condition will run. So after will go to the 3. Current dot next will go to the before. Before will go to the current. Current will go to the here. So this is the full process. I will tell you more clearly. Just give me some time so that I can make it more clear to you, because here it become very hodgepodge. So first of all, I just want to solve it. So let's solve it. Actually, it is already solved. So just remove that. We will solve in Python. Now, first of all, take your current as head, then take a after as none, then take a before as none, and then check the condition while current. So we can update our after is equal to current dot next. Then current dot next is equal to before. Then before is equal to current, and then current is equal to after. This is very simple point. Just only we need to solve this much, and at end we can return the before. If I will return the before, it is solved properly and fully. We can see it. Yeah, see, everything is solved. Like input is 1, 2, 3, 4, 5, and output is 5, 4, 3, 2, 1. And now I let's check it out that it is okay or not. So it is accepting each and everything. Now I just want to show you that how it is working. As right now I show somewhere, but now let me clear it more clear so that you can understand it out more clearly. Right. So is there anything by which I can reduce it? Yeah. So let's keep it the this much code. And now I'm just going to show you everything here by doing dry run. So let's take it one node as one and its next two and its next. This is three and its next four and its next in five and its next. Now, right now, it is showing to this, it is showing to this, it is showing to this, it is showing to this. Right. So this is the net means this is the node and it is the current dot next means head dot next. This is our head. Now, first of all, we will take the reference of head to the current. Why we do this? Like we are providing the reference of head to a current. Why? Just because whenever we will move it means we will move head dot next, head dot next, head dot next, and we will print the head. That time it will not refer to this node. It will refer to the that particular node, and that's how we can lose the reference of these nodes. That's why we are keeping our head secure and we are keeping a new variable here in which we are passing the reference of head. So that's why we mostly means always we do something like this that first of all we pass the head into a variable and then we process it. Now there will be one more pointer as after. After will be null in starting and there will be before which will be null at starting, right? Now, there will be a condition like while dot current. While if current is there, so yeah, current is there. So we will update our after. Means we will update our after. After is right now in null means there is nothing in the linked list. So we are doing after is equal to current dot next. Current dot next is this. So we are moving our after here, right? And then we are updating our current dot next. Current dot next. We are passing it to the before, right? Means we are passing it to a null. Then we are updating our before. Now we are updating our before. Before will come and it will place here at current. Means at head. And then we are updating our current as after. Now we are making our current here, right? Now let me change the pan so that I can like this like our first loop is completed. Now again it will check is the like current came here. Current is here. Now it will check is the current. Yeah, we have current. Current dot next is also there. So we have current. So what will happen? After will update. After will update current dot next. So after will come here. After is coming here and then current dot next. This is the current dot next. It is pointing to before. As right now we updated our before by current, that's why current is equal to before. So current is now, firstly, this node is pointing to here, and now current dot next, this current dot next is pointing to before. Can you see it? Means this connection is lost. Let me erase it out also. This connection is lost, right? And it is, and now new connection is created here. Now, we updated our current dot next by before. Now we are updating our before by current. So before become this. Before came here. And here we have current, and current is came here. Current. Okay, now let me change my pen again for the next iteration. Like after updated, current dot next updated, before updated, and current also updated. Current came here. Now again we will see. Is there current? Yeah, we have current. So what will happen? After will become current dot next. Means after will come here. Right? And see, we will update our current dot next. Current dot next will become before. Before is this one, as we are seeing here. Before is here. So when current and before current are pointing to this connection will lost out. Okay. And this connection will also lost out. Means once current dot next has updated this connection will lost out. Now uh, um, we have after here and current dot next before. Now we will update our before by current. So before came here, and we can update current as after. So current also come here. Now let's do one more last operation. Is there current? Yeah, we have current. So we will update our current as mm, means after. We will update first of all after. So after will be current dot next. So after will come here, and this current dot next means this connection will lost out here, and it will point to the before. See, before is here, and then before again before will update. Before will come here, and current will come here. Now, do we have current? Yes, we have current. So again, current will update current dot next. Current dot next is equal to null. So after will become null this time, and this current dot next will come here, and before will come here. Before is here, and again current is equal to current dot next. So current will go there, and now we don't have current. And see, this one is pointing to this one is pointing to this one is pointing to this, and this one is pointing to null, right? As in the starting, I was telling the same thing. Here, here I was telling the same thing, right? If you remember properly. So this much. So this thing happened here. And this is our code. So I hope you understand it very clearly as I showed it by dry running it properly. So I just hope it will be very clear to you now. So thank you so much for watching it.